Today in the world of math, we are going all the way back to section 3.5. And you might think, why are we going backwards? We were on sections in chapter 9. And the answer to that is that this particular section deals with a lot of, I would call them, tricky concepts. So let's get started. The first concept is function notation, and probably you are pretty good at this. Here is an example from the homework, and it asks you for f of -5 plus f of 1. And in order to do that, we actually are going to do f of -5 first. So that's what I would do, is suggest breaking this up. And so what you're supposed to do with these kind of problems is wherever there's an x in the problem, put a blank, an open parentheses, okay? And then what you're supposed to do is where there was an x, just like here, it says, I don't want x there, I want a -5. And that's what I'm going to do here. The number one mistake that people make in these kind of problems has to do with something like this. Whenever you are going to square something, you will always get an answer that's positive. What is -5 times -5? That's correct. It's 25, not -25. So now what we have is -3 times 25, and then this minus a negative. Do you see that minus a negative right there? What happens with that? It becomes plus. So we have +5 minus 2. That gives us -75. I'll just combine these two, plus 3, which is -72. Okay? Then we would do f of 1 and then add those. We have a lot to cover, and I feel like this function notation is probably the easiest, but you're going to get f of 1. If you do f of 1, let's see, what is that? -3 times 1 squared minus 1 minus 2, 1. So then that gives us -3 minus 1 minus 2, or -6. So in this particular case, for the first one, you get -72 plus a -6, which gives us a -78. In this other case, we get -72 minus a -6. That gives us -72 plus 6. In that case, what is that? -66. There you go. All right. I don't know why I have that twice. I want to talk about, there are a lot of problems in the homework that give you a graph and then ask you for the domain and range and then f of something. So let's first look at these two problems over here. F of -1. So what this says, and typically what we have is, this is asking you for the y value when x is equal to -1. So I'm going to go to here. This is the x being -1. Here is where x is -1. Okay, so f of -1. I'm going to go to the part of the graph right here, and there's only one place where x is -1, and then I'm going to write the y coordinate here, which is 3. So f of -1 is 3. What about f of 0? So here's where x is 0, right here. Here's a point. This point on the graph right here is 0, 4. So when x is 0, y is 4. All right. The other parts are going to ask you for the domain and the range. Now these can be particularly tricky, so be gracious to yourself. Don't get annoyed, don't get frustrated. Domain. Domain is x values. So when we're asked for domain, we are only talking about x values. I am going to read the domain from the left to the right. All right, let's do that right now. So I start at the left. There's no values until I get here, right here. And what is the x value there? Well, the furthest left, that's -2, 0, but the x value is -2. So our domain starts at -2. And by the way, this dot right here, do you see how it's solid? It's solid. That means it's included. And then I travel all the way. What's the furthest right point? It's this one, where x is 1 and y is 3. What do I care about? You guessed it, the x value. The x value here is 1, but the dot is hollow. That means that that value 1 is not included. All right, let's look at the range. The range is y values. Only y values. When I read the range, I go from the bottom of the graph, in other words, the lowest point, to the top of the graph, the highest point. So, in this particular case, let's see. I'm going to erase this. I start at the bottom of the graph and read, where is the bottommost point? It's this one, right here. That point is -2, 0. What am I looking at? The y value. The bottom y value is 0, and it's included because our dot is solid. Then I continue up the graph, and I go to the tippy top point, which, by the way, is here. Okay? The point there is 0, 4. So the top y value, remember, it's just y values, is 4. Is 4 included in the graph? Yes, as long as it is not hollow, it's included. So our domain goes from -2 to +1. Our range goes from when y is 0 to when y is 4. This can be tricky because if you don't focus on like what's the x value, what's the y value, then it is easy to get confused. Finally, you are going to be asked for the domain of certain equations, certain functions. So you need to know that there are two things that are against the law in math. The worst crime in math is to ever divide by 0. You can never have a 0 in the denominator. So if you have a fraction, f of x equals, I'm just going to say a over b, the way to find the domain is to say, oh b, Mr. B, you, denominator, you can never be equal to 0. Okay? The other item that is against the law in math is to have a negative under an even radical, or in this case, a square root sign. So, when you have something like f of x equals the square root of, I'm going to say smiley face, or just there, then what you do is you take out from under the radical what you have, and you say you better be greater than or equal to 0. What it is to be negative is to be less than 0. So if you want something 0 or positive, whatever is under the radical must be greater than or equal to 0. So let's do 2 examples. In this first example, I'm asked for the domain of a function. In this particular case then, what do I focus on? I don't even care about the numerator. All I care about is the denominator. And do you know what I tell the denominator? Yo, denominator, you darn well better not ever be equal to 0. I use, in this case, the AC method. A times C is 1 times negative 8, which is negative 8, and I have to think of 2 numbers that multiply together to give me negative 8, but when I add them together, I get negative 2. Those numbers are negative 4 and positive 2. Are you getting better at those? And then I divide those by A. In that case, it's just 1. So when I factor this, it gives me x minus 4 and x plus 2. And I say you guys are not ever allowed to be equal to 0. So when I take these out, I say x minus 4, you can't be equal to 0 either. And then I add 4 to both sides, and I tell x, hey, if you're ever 4, then that means that this denominator would be equal to 0. And I don't want to go to math prison, and I'm not going to break the law. And then here we tell x plus 2, dude, you're not allowed to be equal to 0 either. I subtract 2 from both sides, and those are my 2 answers. Now, let's work on an example from the second thing where you're not allowed to have a negative under a square root. In this particular case, you're asked for the domain here. So what do? We take what's under the radical. Excuse me. That's what happens when I make a video in the morning. I'm still scratchy. All right. So then we say, okay, negative 8x minus 5, I just take out from the radical, and I say, well, whatever happens, you better be not negative, or greater than or equal to 0. So from there, I draw my line of equality. I'm going to add 5 to both sides. So I get negative 8x is greater than or equal to 5. Divide both sides by a negative. Oh, do you remember the rule about dividing by a negative? When I divide by a negative, I have to flip the inequality. Don't forget about that. So x is less than negative 5/8. Here's negative 5/8. If I want to write this in interval notation, it goes this way. This way is toward negative infinity. So it goes from negative infinity, which always has parentheses, to negative 5/8. And I have to have a bracket here. Why? Because of this or equal. Remember, or equal means that that value is included. I know I went through these very fast because there's a lot of concepts in this particular section, but I will go ahead and add supplemental videos to this one, or hit me up. I'm always happy to answer your questions. Have a great day.